Hi everyone, welcome to my channel. Let's talk about exploring carbon nanotubes, the tiny marvels of the nano world. If you like my content, please share, like, and subscribe to my channel. Now, let's begin our story. Carbon nanotubes are tiny cylindrical structures made entirely of carbon atoms, arranged in a beautiful hexagonal pattern, like a rolled-up sheet of graphene. Once upon a time in the world of nanoscience, scientists discovered a structure so tiny yet so powerful, it could change the future of technology. These were called carbon nanotubes. These nanotubes were no thicker than a strand of DNA, yet they possessed strength hundreds of times greater than steel. While being incredibly light, they were so thin that millions of them could fit inside the width of a single human hair. Yet they were stronger than almost any material known to humankind. They were born from sheets of graphene, single layers of carbon atoms, rolled into perfect cylinders, creating a structure both elegant and immensely strong. This perfect roll of graphene gave carbon nanotubes extraordinary electrical conductivity, making them capable of carrying electricity better than copper. This meant that one day, they could be used to make ultra-fast, energy-efficient electronics, far beyond the capabilities of today's devices. Engineers began to dream of flexible, paper-thin computers and wearable devices powered by these extraordinary nanotubes. Scientists in labs across the globe worked tirelessly, experimenting, testing, and perfecting carbon nanotubes for real-world applications. They envisioned airplanes with bodies made from nanotubes, lighter, stronger, and more fuel-efficient than anything ever built before. They imagined space elevators, gigantic cables stretching from Earth to orbit, made possible only by the unmatched strength of carbon nan. They even saw a future where nanotubes could deliver life-saving medicines directly to the cells that needed them most. They could be engineered to target diseased cells with pinpoint accuracy, releasing treatment exactly where it was needed, reducing side effects and saving lives. With their unmatched strength, remarkable electrical conductivity, and incredible versatility, carbon nanotubes hold the promise to transform industries from electronics and medicine to aerospace and beyond. And so, the story of carbon nanotubes is still being written, each discovery bringing us closer to a future where these tiny tubes reshape the very fabric of technology and human progress. From the circuits in our devices to the structures that may one day take us to the stars, carbon nanotubes stand as a reminder that sometimes the smallest things can hold the biggest possibilities. Researchers are now exploring how to mass-produce carbon nanotubes efficiently, aiming to make them affordable enough for everyday products, from ultra-strong bicycle frames to transparent, flexible phone screens. In laboratories, prototypes of bendable solar panels made with carbon nanotubes are already capturing sunlight more efficiently than traditional silicon cells, hinting at a cleaner and more sustainable energy future. Scientists are also combining carbon nanotubes with other advanced materials, creating composites that can self-repair, resist extreme temperatures, and even adapt their properties depending on the environment. In the realm of medicine, researchers are experimenting with nanotube-based biosensors, tiny detectors that can spot diseases in the bloodstream long before symptoms ever appear, giving doctors a head start in saving lives. Military engineers are testing nanotube-infused armor that's lighter than Kevlar, yet capable of withstanding greater impacts, offering soldiers and vehicles unmatched protection without sacrificing mobility. In space exploration, carbon nanotubes could be used to build ultra-light spacecraft, reducing launch costs and allowing for larger payloads, potentially making deep space missions more practical and frequent. Some visionaries even imagine entire cities built with carbon nanotube reinforced materials, skyscrapers that sway safely in earthquakes, bridges that last for centuries, and infrastructure that needs almost no maintenance. And while the full potential of carbon nanotubes is still unfolding, one thing is certain: they are poised to be one of the most revolutionary materials in human history, quietly shaping a future that's stronger, smarter, and more sustainable. In the end, carbon nanotubes remind us that big revolutions can come from the tiniest scales. From powering next-generation electronics to enabling space travel, from healing the sick to building cities of the future, these microscopic marvels could define the next chapter of human innovation. The story of carbon nanotubes is not just about science, it's about possibility. And as we continue to explore, invent, and dream, these tiny tubes may well become the threads that weave together the fabric of tomorrow.